There is something profoundly ironic in the fact that humanity, while gazing at the stars in search of new worlds, risks making uninhabitable the only space truly accessible, the one surrounding Earth. Just a few hundred kilometers above our heads, in that invisible belt stretching from low Earth orbit to the boundaries of cislunar space, a decisive game is being played for the future of space exploration as a whole. It is the challenge of orbital sustainability, a question as technical as it is existential, which today imposes itself as one of the most urgent problems of our era. When one speaks of space, the mind immediately leaps to distant planets, interstellar missions, spectacular visions of galaxies and black holes. But what is happening just beyond Earth's atmosphere is just as dramatic. At present, there are more than 11,500 active satellites in orbit, according to data updated to 2025, and this number is set to exceed 100,000 by 2030 with the proliferation of the so-called mega-constellations for telecommunications, such as those operated by Starlink, OneWeb, and Amazon Kuiper. So far, it might seem like progress. But the price to pay for this revolution is unprecedented congestion. For every working satellite, there are dozens that are decommissioned, fragmented, exploded, or simply lost. According to the European Space Agency, there are an estimated 36,000 fragments larger than 10 centimeters, more than 1 million between 1 and 10 centimeters, and over 130 million microdebris smaller than a centimeter, still capable of piercing shields and fuselages at orbital speeds exceeding 25,000 kilometers per hour. Every lost screw, every shattered panel, every metallic shard is a potential threat. This phenomenon has a name: the Kessler Syndrome. Formulated in 1978 by NASA scientist Donald J. Kessler, it hypothesizes a tipping point where the density of objects in orbit becomes sufficient to trigger a chain reaction of collisions. Each crash generates new debris, which in turn cause further impacts. The result? An exponential escalation that could render the entire low Earth orbit unusable for decades or even centuries. And it is not just theory. On February 10, 2009, a decommissioned Russian satellite collided with an active one from the Iridium network at an altitude of 800 kilometers. The collision generated more than 2,000 trackable fragments, an event that forever changed the rules of orbital safety. Similar, though smaller, incidents have continued to occur. In 2021, a Russian anti-satellite test intentionally destroyed a satellite in low orbit, generating a cloud of debris that even endangered the crew of the International Space Station. The sustainability of space is not merely an ecological issue. It is also geopolitical. Every nation, every company, every space agency is today part of a chaotic ecosystem, devoid of a central authority, where the rules are vague and often disregarded. Existing international agreements, such as the 1967 Outer Space Treaty or the 2019 UN Guidelines, carry no binding force nor enforcement mechanisms. In practice, whoever launches satellites is responsible for their debris, but there is no real global jurisdiction capable of mandating recovery or prevention. Thus, we find ourselves in a modern paradox. Humanity's most advanced infrastructure, our orbital infosphere, is also one of the most fragile. Every new launch risks being the last step toward a silent yet devastating collapse. For if space were to become inaccessible, entire networks of communication, navigation, meteorology, even military operations and banking systems would be compromised. Our world already depends on space far more than it seems. But not all is lost. In the face of the threat, technological responses and pioneering initiatives are emerging. Some startups are developing active debris removal technologies, such as space harpoons, electromagnetic nets, robotic cleaning vehicles, or laser systems to deorbit micro-objects. The ESA has launched the Clear Space 1 mission, scheduled for 2026. With the goal of capturing and removing a 112 kg piece of debris left in orbit since 2013. At the same time, NASA, JAXA, and private companies are testing autonomous propulsion systems to ensure that satellites can self-destruct or deorbit at the end of their operational life. However, the real challenge is not only technical but cultural. As with climate change, the problem of space sustainability requires collective awareness, a shared responsibility. Because space, ultimately, is not just a place. It is a mirror. And just like on the planet observing it from below, up there too humanity risks leaving more traces of destruction than of exploration. If today we gaze at the stars imagining lunar colonies, Martian outposts, and interplanetary journeys, we must also ask ourselves, what is the point of dreaming of other worlds if we cannot take care of the orbit that surrounds us? It is a question that concerns not only scientists or aerospace engineers, but the entirety of technological civilization. Space sustainability is a test bench for humanity's collective intelligence. And the next 10 years will be decisive. It is no coincidence that the UN has included space management among the new frontiers of the 2030 Agenda for Sustainable Development. For the first time, trajectories of economic growth, technological innovation, and international security are converging on a common point: the need for a space ethic. Because Earth's orbit has now become a global public infrastructure, just like the oceans, the atmosphere, or cyberspace. And as such, it requires rules, maintenance, responsibility. But how does one build an ethic in the absence of borders, property, or orbital police? Some proposals in this direction are already taking shape. The International Telecommunication Union has begun imposing limits on operational lifetimes for satellites in geostationary orbit. NASA, through its Orbital Debris Program Office, is pushing for stricter guidelines on payload design, requiring, for example, that every satellite include a deorbit plan within 25 years of mission end. And new startups are exploring the emerging business of space servicing, that is, in-orbit maintenance, refueling, and even repair of active satellites, extending their lifespan and reducing the need for new launches. Beyond the technical aspects, however, space sustainability might also become an opportunity for planetary cooperation. In a world divided by earthly conflicts, space offers, paradoxically, one of the few arenas where scientific collaboration has always prevailed. The International Space Station, an emblematic example of coexistence among space agencies from countries with opposing geopolitical interests, is the concrete demonstration of how space can unite. Today, that same spirit can be placed at the service of orbital preservation. Imagine a binding international treaty, signed by all space powers, imposing clear rules on satellite end-of-life, mandatory fragment tracking, shared liability for collisions, shared radar data to monitor space traffic. Imagine a global network of observatories, sensors, and algorithms able to predict and prevent every impact, every fragmentation. Imagine autonomous vehicles patrolling orbit like ecological drones, collecting debris, repairing probes, disposing of wrecks like cosmic street cleaners. This is not science fiction. It is already the present in the making. In 2023, Japan launched the first test of a satellite equipped with an electrodynamic tether sail for controlled deorbiting. In Switzerland, ClearSpace is designing robotic systems inspired by the human hand, capable of grabbing and dragging objects out of orbit. And in Houston, startups like Astroscale are perfecting SpaceTug systems that can push obsolete satellites toward safe atmospheric re-entries. But the question remains, will it be enough? Will we manage to act before Kessler's syndrome becomes reality? Time is running out. Every new rocket launched into low Earth orbit increases the statistical risk of collisions. Every second, millions of invisible fragments orbit above us, ready to turn into ultra-high energy projectiles. And every mistake could mean GPS blackouts, interruptions in satellite communications, loss of meteorological observations, chain disasters in global systems. And yet, behind the emergency lies an opportunity. The opportunity to reinvent our relationship with space, no longer as a frontier to exploit, but as an ecosystem to preserve. As a new artificial biosphere where physical laws are relentless, but responsibility lies entirely with us. Perhaps this is where space teaches us its most important lesson. It is not enough to conquer new worlds. We must learn to keep them livable. At every altitude. On every orbit. In every possible future. And if humanity proves capable of protecting Earth's orbit from itself, then perhaps it will also be ready to inhabit other planets. For the true conquest of the cosmos does not begin with the first step on the Moon, nor will it end with the first landing on Mars. It begins, and will continue, with every small gesture of care toward the space that keeps us connected, informed, alive. A silent, invisible, fragile space. But ours. From today, forever. If you've made it this far, it means you love curiosity as much as we do. If you enjoyed this journey, leave a like, write a comment, and subscribe to the channel. It's the best way to support what we do. Your presence truly makes a difference. Until the next exploration.